Welcome, agents. Your mission today is highly sensitive and absolutely critical. Your objective? Extract maximum marks from a hostile Cambridge 9709 mathematics paper under intense, unforgiving time pressure. I am your strategist, and today we are targeting the most notoriously guarded area of the entire syllabus. We're talking about mastering integration using complex trigonometric identities. Listen, every single year, thousands of candidates walk into that exam hall, trigger the exact same examiner tripwires, and completely lose their shot at those top marks. We are going to ensure you are not one of them. You're going to learn how to break down an exam paper like a highly trained operative. But before we brief you on the extraction protocol and hand over the exact tactical blueprints, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. All right, let's initiate the briefing. So, what is the real difference here? What truly separates a B grade from an A star? Consider two candidates facing a classic extraction scenario. Let's say they're asked to evaluate the integral of sine squared x from 0 to pi over 4. First, we have Alex. Now, Alex treats the exam paper like a desperate data dump. He overloads the page with raw double angle formulas, random trigonometric identities, and unstructured facts, just crossing his fingers and hoping anything sticks for a method mark. Then we have Sam. Sam feels the immense pressure of the ticking clock, panics, rushes the operation, completely misses the specific command word requirements, and forgets to apply the boundary limits at the end. Both of them bleed critical marks. Why? Because they're relying on raw, brute force calculation while completely ignoring the examiner's playbook. Achieving that A-star tier is not just about memorizing every single mathematical fact from the textbook. It's a calculated, tactical operation. It requires knowing precisely what the assessment objectives are and executing a targeted strike to secure every available point. It's about working smarter, not harder.
Section 1. Core Principles and Theoretical Foundations.
To really grasp this, let's look at how top students operate compared to the average. Alex's approach of just throwing facts at the page, it's like throwing puzzle pieces at a wall. It relies on a very superficial breadth of knowledge with absolutely zero structural integrity. When average candidates see a trigonometric integral that looks even slightly different from the exact one they practiced in their textbook, total panic sets in. But top-performing candidates, the elite agents, they build a connected, conceptual bridge. They possess the analytical depth to transfer their knowledge seamlessly to completely unfamiliar integrals. They do this by utilizing a highly effective framework tailored specifically for pure mathematics, often referred to as the Peel framework. That stands for principle, equation, execution, and limit check. First, they state the mathematical principle. Next, they lay down the correct trigonometric equation. Then, they flawlessly execute the calculus. And finally, they rigorously check their limits. We're going to use this framework to rebuild Alex and Sam's answers from the ground up, turning red pen marks into green check marks. But before we move deeper into how you can deploy this exact framework in your next paper, I need you to listen closely. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now to secure your tactical advantage.
Now, directly from the principal examiner reports, the intel we've gathered is crystal clear. Quote, candidates referencing cross-topic connections achieve significantly higher marks, unquote. This is a massive revelation, folks. The theoretical architecture of calculus does not exist in a vacuum. If you want to elevate your grade, you have got to fuse your knowledge of differentiation, polynomial behavior, and trigonometric identities into one cohesive, unbreakable mathematical solution. Examiners are actively scanning your paper for this exact type of cross-topic mastery. When you show them that you understand integration is simply the reverse engineering of differentiation and you confidently manipulate a complex cosine double angle identity to break down a squared trigonometric function, you immediately signal that you are operating at an elite A-star level. You are no longer just answering a question. You are demonstrating total, undeniable mathematical fluency. You're showing them you see the whole matrix.
Section 2. The method mark strategy. Okay, when tackling these complex 9709 examination questions, you absolutely must execute a flawless procedural blueprint to guarantee your method marks. These are the crucial marks awarded for deploying the correct strategy, even if your final numerical answer somehow slips away under pressure. Here is your 5-step extraction sequence. First, deconstruct the command word. Is it asking you to show that, to evaluate, or to find the exact value? Each one of those phrases requires a totally different operational approach. Exact value means if you write down a decimal, you lose, period. Second, extract your boundary conditions and variable data. Third, select your analytical framework.
This is the moment where you identify that, hey, sine squared x cannot be integrated directly. It must be transformed using the identity 1 minus cosine 2x all over 2. Fourth, execute your strategy with crystal clear notation. And finally, present the outcome with mathematically rigorous terminology. Let's watch the transformation happen. If Alex stops data dumping and applies this logical sequence, those raw, messy facts turn into a structured, step-by-step proof. If Sam stops rushing and applies this sequence, those forgotten boundary limits are locked in securely right from step 2. It is a total game changer. It's really crucial to understand that even in pure mathematics, it's not just about crunching numbers on a calculator. It is deeply rooted in advanced data interpretation. Throughout the exam, you are constantly extracting boundary values, interpreting the intricate relationships between distinct trigonometric functions, and drawing evidence-based conclusions. And you have to do all of this while strictly adhering to Cambridge conventions. That means perfect algebraic structure, clear annotations for any substitution you make, and carrying your dx through every single line of working until the integral is fully resolved. Let's initiate our first interactive workshop right now. Challenge 1, the data scan. I want you to imagine a complex integral on your exam paper, featuring a mix of secant squared and tangent functions. You have exactly 60 seconds on the clock. Mentally scan that relationship. Your tactical objective is to immediately recognize the Pythagorean identity connecting them. Tangent squared x plus 1 equals secant squared x. Boom. The time starts ticking the moment you flip that page. Your presentation and your logical argument must be entirely watertight to survive the examiner's scrutiny. Section 3. Top 3 examiner warnings. But wait, stop scrolling. Subscribe to our YouTube channel, Ace the Exams at acetheexams_IGCS to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCS and turn on all notifications so you never miss our weekly exam strategy sessions. All right, we are entering the high-risk zone. Examiners flag 3 critical, unforced errors year after agonizing year. Number 1, forgetting the proper format. This usually means abandoning the constant of integration, that crucial plus c in your indefinite integrals, or dropping the differential operator dx entirely. Number 2, sloppy presentation conventions. This is where one line of calculus bleeds into the next without any clear logical flow, making it literally impossible for the examiner to award you those precious method marks. Number 3, generic answers that entirely ignore the specific context or limits given in the prompt. Let's test your reflexes with our second interactive workshop, the Find the Flaw Challenge. Visualize a paragraph of mathematical working right in front of you. A candidate successfully integrates cosine 2x to get 1/2 sine 2x. Great. But then they evaluate the boundary limits in degrees instead of radians for a calculus problem. You have 60 seconds. Identify the error. Time's up. The flaw is fatal, agents. Calculus operations on trigonometric functions absolutely mandate the use of radians. Taking the derivative or integral of a trig function assumes radian measure. Missing that specific context? That is an instant mission failure. So how do we combat these devastating unforced errors? We deploy a high-level memory hack. You need to create a custom mnemonic using the first letters of your critical terms to ensure you never, ever miss a formatting requirement under the stress of the exam room. Let's move to Challenge 3, the speed writing challenge. You have 30 seconds to lock this in. I want you to mentally install a foolproof checklist for every single integration problem you face. Ready? Identity, notation, substitute, evaluate, radians, INSER, insert. Let's run it again. Identity check, notation check, substitution check, evaluation check, radian check. Having this mental framework deeply installed into your operational memory means you execute perfectly under the ticking clock of the exam timer. You stop relying on luck, and you start relying on a hardened, battle-tested tactical system. Section 4. Achieving Evaluative Mastery. Now, the ultimate goal here is to shift from being a mere human calculator to operating with absolute evaluative mastery. Top-scoring, elite candidates operate as critical evaluators. When they are faced with a brutal high-mark integral, they don't just put their head down and start writing blindly. No. They pause, they question their assumptions, they ask themselves, wait, is this definitely a U substitution mission, or can I deploy a sneaky double-angle identity to bypass the complexity entirely and save myself 4 minutes? They consider different mathematical perspectives. They rigorously justify their analytical decisions with clear evidence right there on the page. This depth of thought is heavily prioritized by the Cambridge Assessment Framework. You are basically proving to the examiner that you are in total command of the mathematical landscape. You're directing the flow of the solution rather than just nervously reacting to the numbers on the page.
And here is the absolute golden rule coming to you straight from the examiner alerts. Always link your mathematics to the specific given scenario. Never leave your calculations floating out there in the abstract void. This brings us to the final success system, the 3 unbreakable rules that absolutely guarantee top marks. Rule 1. Command word decoding. If the paper says exact value, giving a rounded decimal answer is immediate self-sabotage. Rule 2. Rigorous Peel framework application. Principle, equation, execution, limit check, every single time. Rule 3. The time management matrix. This is huge. You must allocate exactly 1.5 minutes per mark. Let's do the math. If a trigonometric integration question is worth 6 marks, you have exactly 9 minutes to extract those points before you must abort and move on to preserve the rest of the mission. Tie every single mathematical conclusion directly back to these 3 strict operational rules, and your mark potential goes from 0 to 100%. The mission parameters are set, agents. So I leave you with this. How will you actively apply this exact extraction strategy to deconstruct your very next trigonometric integration past paper? Are you going to operate like Alex, dropping data blindly onto the page, like Sam, rushing headfirst into traps, or will you execute the blueprint like a true strategist? Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.